So today is the official first day of trigonometry where we are starting 4.1. And 4.1 is just filled with all kinds of information. It's a lot about terminology and notation and different things, everything about angles, which is where a lot of trigonometry revolves. So today I actually split up over 2 days. It's a lot of info. We're just kind of getting the hang of some relationships, getting the basics down today. So all about angles. So starting off, when we talk about angles, we usually reference them in terms of being in standard position. And standard position means that you take the initial side and you put it over here along the x-axis, on the positive x-axis. And then the terminal side kind of wraps around to create this angle. We oftentimes use Greek letters, mentioned that earlier, Greek letters to represent angles in trigonometry. So instead of angle A or angle B, like you did in geometry, this is angle theta. Here is a beta. Here's an alpha. Just you'll get familiar with some of these Greek letters. So when an angle is in standard position and it has that initial side right here, you can create either a positive angle by doing the same old thing that you would have done in geometry, which is to wrap it this direction, counterclockwise. But if instead you have the initial side here and you decide to back up, that would be considered a negative angle, maybe a negative 45-degree angle or something. So positive means you wrap counterclockwise, negative means that you're actually going clockwise. Oh, and to distinguish those, you have to put this little arrow. Now, we will typically default to a positive angle measurement, but we also will have angles that like wrap around multiple times, and you kind of have to have this arrow to show that. In this case, the arrow is showing that it's going backwards, so that's a negative angle. That's what those arrows are for. So the first way you've learned how to measure degrees is, or measure angles, is with degrees. That's what you did in geometry and all the years before. So a degree is really just 1/360th of a circle. So a very, very small piece of all the way around of a circle. So 360 is kind of a weird number. Where did that come from? I don't know, but that's what it is. Now, when you start dealing with degrees, sometimes you'll have a decimal part of a degree, and you can break that decimal part down into degrees, minutes, and seconds. You would have seen that with like longitude and latitude is measured in degree, minutes, seconds. Let's talk about how to do that. Here I have an angle that is measured in degrees, and it's a 0.568 of a degree going on. So because it's 360, it actually works very nicely if you think about a clock. So when I see a 0.568, well, that's over half of another degree. So the minutes part of this would be, oh, then it's about 30, over 30 minutes. That's what that's meaning, that 0.56. It's not 56 minutes or 568 minutes or anything like that. It's a portion of a degree, and minutes and seconds are broken down by 60s, just like on a clock. So when I'm doing this, what I need to do is I need to take the 0.568 value and just take it times 60. So in my calculator, I got mine handy, I hope you do too, 0.568 times 60, and I get 34.08. Now, I am not doing tons of examples, so you need to take some good notes, some clean notes, so you can come back to this stuff. I'm taking the decimal part times 60. And what I get then is 73 degrees and 34.08 minutes. And minutes are marked with a little hash mark up there. Now, what I want to do next is take this 0.08, and this is going to have to be a portion of a minute. And to turn minutes into seconds, well, there's 60 seconds in a minute. So I'm going to do the same thing with this decimal part here. I'm going to take my 0.08 and I'm going to take it times 60. So then I'm going to have 73 degrees, 34 minutes, and if you take 0.08 times 60, you get 4.8 seconds. But typically, we will not write that as 4.8. By the time you get down to that small of a measurement, we go ahead and just round that off. So we're going to write this 73 degrees, 34 minutes, and 5 seconds. Double hash mark on the seconds. Now, this one actually came out nice to this 4.8, or the 34.08 was exact. Here's a little calculator hint. If this was like an ongoing decimal, you kind of need all those decimals, but rather than retyping them, when I'm sitting there looking at this 34.08 number, I just do a quick minus 34, and then what I have left is the full decimal value. And then I'll always have full values as I'm multiplying. And so same thing with on anytime you have a decimal part, just subtract off the whole number. All right, next, let's go the other direction. Now, it's nice when it's in this degree, minute, seconds. It is a nice way to display your longitude and latitude. However, it's not very easy to do math with. We'd prefer the decimal value to do math with. So now sometimes we're going to have to convert back. The quickest way I have found to do this is just do it one shot in your calculator. And I'm going to take all of this and convert it to degrees. So I'm going to take 46 plus, now 43 minutes is a portion of a degree. If I take the 43 and divide it by 60, it will get me the decimal part of a degree. Plus, and this is where it gets a little trickier, I'm going to take my 18, and I can't divide the 18 by 60 because that would only convert that to minutes. I have to convert it clear back to degrees, so I have to divide it by 60 twice, which really is the same as dividing by 3,600. That's 60 times 60. And then I just type that in my calculator, left to right, no parentheses, just type it in, and it works great. And I end up with, and then it'll tell you what to round to, oftentimes to the thousandths. So I'm going to write this 46.722 degrees. And then I can do math with that number more easily. And just so that that sort of makes sense, think about 43 minutes. If you think on a clock, that's about 3/4 of an hour, right? And look at where I'm at, about a 0.75, so about 3/4. That's where that decimal comes from. The next thing that I want to talk about on angles is looking at this radians and what we've talked about so far with radians. And we know that 1 revolution is equivalent to 2 pi radians. Those are angles in there. That's how many angles I could fit in. All right, so if you look at this, theta, which is our angle here, can really be found by taking this arc length you have here and dividing it by how many radiuses will fit. So if you can fit 1 radius, 2 radius, then that means that, or 2 radii, that means that if you take your arc length, which was 2 of those strings, as what I think of it as, you divide it by your radius, how many of those fit in there, that's telling you what your theta is, how many radians that would be. So looking at this example, if I measured out this arc length and it ended up being 6 centimeters, and I know that my radius is 2 centimeters, then how many of those 2 centimeters are going to fit on there? And what that represents is your angle measured in radians. So this one, I made the numbers really nice. So that is going to be equivalent to 3 radians. Now that's something we're going to follow up on tomorrow, that concept there of the relationship between the theta, the arc length, the radians, all of that. All right, so because we now know degrees and we know radians, we really do need a way to convert back and forth between the two. We don't want to be too dependent on degrees where we're always going back to degrees to do stuff. We're going to be familiar with both degrees and radians, but they each have their role, so we do need to be able to go both ways. I have these eyeballs here, meaning you're just watching here. Don't even write this down. I would rather you just watch this because we're leading up to something. Just watch me. I know lots of people just can't stop themselves from taking notes, but really, I promise, just watch. If I have a degree measurement, in this example, I have 200 degrees, and I want to figure out what that would be in radians. Now, in my head, now 200, I'm talking about, these are angles that are not on our unit circle. We are going to know the unit circle ones. Those are going to be, just come to us in our head. But sometimes there are things that aren't on the unit circle. So that's what we're dealing with here. 200 degrees. As pretty as it is not one of the angles on our unit circle. Now, I could ballpark what I feel like that is. Because of where that is past 180. And I'm down in the third quadrant there. So I know then that in radians, this number here better be bigger than pi, because this is bigger than 180, and pi radians would be 180. Now, here's what we would really do. I'm going to use the relationship that pi radians is the equivalent to 180 degrees. And I'm just going to set up a proportion. If that's true, then that means 200 degrees, so I'm going to put 200 on the bottom with degrees, would be x radians. And it's just a proportion that we would solve. So doing cross products, you can see you'd have 200 times pi equals 180 times x. And then you're going to divide by 180. And that's what we get for our angle measured in radians. So it's 200, and I could, of course, reduce this, 200 pi over 180 radians. Now, here's the thing. If I were to do this and I change 200 to 300, well, 300 is on the unit circle. Let's say 301, or let's say it could be 700. It could be 143. Whatever the angle is, the process of doing this proportion would be the same every single time. I would just have a different number here. But I would immediately take my number, whatever the degrees were, and I would take it times the pi, and then I would come back and end up dividing by 180. And if that process is the same every single time, I feel like we could be more efficient than having to set up a proportion every time. Couldn't I just take the degree measurement they gave me and take it times pi divided by 180? All right, go ahead and jot that down on the next slide. I don't even remember if I gave you this slide in your notes. But ultimately, to get from degrees to radians, you're going to take your degree measurement and you're going to multiply by, and the reality is I'm going to do it all in one shot. I'm going to multiply by pi while I'm dividing by 180. I'm going to multiply by pi over 180. Okay, let's look at this another way. Let's say I'm going from radians to degrees. And I purposely gave us kind of an icky one here. 4 pi over 5 radians, and trying to figure out how many degrees that would be. But before we do it, I'm going to make you think a little bit. 4 pi over 5, that's like 4/5 of pi. Do you know what quadrant that should fall in? If you're 4/5 of the way to pi. I hope you're thinking second quadrant, because 4/5 of the way to pi would be somewhere like here-ish, 4/5 of the way, because pi is straight across. So I'm going to get some sort of an angle up here. Let's see if we really end up with that. I'm going to do the same thing we just did. I'm going to take pi radians over 180. And that's in degrees. So that means I'm putting radians on top, degrees on bottom. So I'm going to put my 4 pi over 5 radians and put it over x degrees. I'm looking for how many degrees would that be? So let's see how we would do this. We would do cross products again. So I'm going to take and multiply the 4 pi over 5. I'm going to multiply it by 180. And that's going to equal x times pi. And then I'm going to come back and I'm going to divide by pi to isolate the x. So what did I really do with my radian measurement? Here's my radian measurement. I multiplied it by a 180 divided by a pi. Look at how that compares. It's the reciprocal of that. You're going to multiply by 180, divide by pi. So let's just cut to the chase. Do I really need to do the proportion every time? If I'm trying to go from radians to degrees, I'm going to multiply by 180, divide by pi. Let's jot it down on the next page. To go from degrees to radians, we're going to multiply by pi over 180. If I want to go the other direction, I'm going to multiply by 180 over pi. All right, I do have kind of a trick that works. This is what I do in my head when I'm trying to remember which way do I go with this. I think of if I am going from degrees to radians, I'm trying to gain a pi somewhere in my answer, so I put pi on the top. But if I'm trying to go to radians 2 degrees and I'm trying to get rid of the pi that's already there, then I would want pi on the denominator because the first thing it's going to do is that's going to cancel out. Let's practice with a few. So converting angles. The first one, if there's a pi sitting there, we're going to assume that is in radians. So we want to go 2 degrees. So because I'm trying to get rid of the pi, I know pi is going to go on the bottom. So this is the version where I take it times 180 over pi. The pi's immediately cancel. You do want to reduce, probably smart to reduce before the numbers get too large. 8 does not go into 180, but 4 does. So I'll reduce these both by 4. And then I'm just going to go ahead and take my 5 times the 45 divided by a 2, and I have 112.5 degrees. On the next one, you have 130 degrees, and you want to convert that back to radians. So in my mind, I'm thinking, all right, that means if I'm going to radians, I want to get a pi in the answer. So I'll put that on top, divide by 180. Think of your 130 as over 1, and let's do some reducing. I know these could both reduce by 10, so it's really a 13 over 18. And 13 over 18 doesn't reduce, so I'm just left with 13 pi over 18. I don't have to label it because we assume it's in radians unless we see the little circle. So there's my answer, 13 pi over 180. Again, just common sense in your head, 130. I don't know if that's common sense. I just want it to make sense in your head. 13/18 is less than 1. So I should be less than 180. Yep, I am. But it's bigger than a half because that'd be 9/18. So that's why I know it's going to fall in this quadrant, and there I am with my 130. Over here, I see a 5/8 pi. Well, 5/8 is less than 1. It's also bigger than 4/8, which would be a half. So again, this one, that should clue me in that I'm over here in this quadrant, and yes, I am. But 5/8 is a lot closer to 4/8. So it's closer to the 1/2 mark, or the 90, straight up. All right, hope that's starting to make sense. Next one. This is just a 4.6. Seems weird. It's not a degree because there's not a degree symbol. So it's a 4.6, but it's in radians. And what they've done is they've gone ahead and approximated it rather than leaving pi in the answer. They've like typed it in their calculator and got some sort of a decimal approximation. So before we get started, can you approximate in your head, could you point to 4.6 radians? Where would that be? Remember that this is pi radians. So right there, I'm at 3.14. So 4.6 is probably somewhere down here-ish. And this is where I'm landing. There's my 4.6 radian angle. Let's see if we're right. All right, so even though it doesn't have a pi in it, I in my mind think, all right, it's a radian, I got to get rid of the pi, so the pi is going to go on the bottom. So I'm multiplying by 180 over pi. And it's already a decimal. There's no sense in trying to keep this exact with a pi in it. So I'm just going to go ahead and go straight decimal. It's going to degrees. I'm going to take 4.6 I'm going to take it times the 180 and divide it by the pi button on your calculator. And I end up with 263. And I'll just go one decimal place here, 0.6 degrees. And yeah, we were pretty good right here because remember, straight down is 270. So we're pretty close to straight down with that one, 263.6. Don't forget, because we went to degrees, you got to put your degree symbol on there. All right, so I did 3. Now it's your turn to do 3. So what I want you to do is pause the video now and practice these 3 without any help. Once you've done those 3, then turn the video back on and come back to me. All right, so here are my answers. Do you agree with mine? Hopefully so. I do want to comment on one thing that I'm sure that you just plugged and chugged through it and didn't think, but I'm going to make you think here. Look at where 480 would be. 480 is bigger than 360. So what you have done is you have wrapped around that circle. It goes zoom and it goes around something like that. That's what you start doing when, and you do like that. But notice that because it wrapped around past 360, can you evaluate what's 8/3? That's actually bigger than 2 pi. And so that's why that should make sense is, oh yeah, I went past 360. So my fraction here should be bigger than 2 pi. Same thing on this next one, 9.1. I already showed you up here, there's pi radians, that's 3-ish. So over here is 6-ish. So 9-ish is over here somewhere. And of course, it starts to get off a little bit, but you can see that it's wrapped around multiple times, which is why we're getting bigger than 360 for an angle there. All right, so the next topic for our angle lesson here, we have something called coterminal angles. And these are angles that have the same initial side. They even have the same terminal side. So they look like they're going to be identical, but they're not because they've wrapped around the circle differently. This is sort of like when I said earlier that 0 degrees and 360 degrees are not the same. They land in the same place, but they would be considered coterminal. So you might have an angle that looks like this. And we'll just say, let's just make our life easy. Let's say it's a 100-degree angle. Okay, great. But I could have another angle that looks just like it right here. And instead of it being 100, I'm going to do something like this and wrap around to show you, oh, this isn't 100 degrees. This has been wrapped around a few times. And so what we're trying to do is find some of these coterminal angles. In addition to doing it like that, where it's wrapped around a few times, maybe instead it backed up and it was a negative angle, but it still could be a coterminal angle if it landed in the same spot as the original. So the only difference between these coterminal angles is 360 degrees. It's wrapped around one way or the other way. So what we're doing is to find positive and negative coterminal angles. So this one's an 80 degrees, so we're just right here. I want to find one positive and one negative coterminal angle. Well, I'm going to go ahead then, and I'm just going to take my 80, and I'm just going to add a 360 to it, and that's going to be a positive coterminal angle. Likewise, I could, instead of going towards the 80, I could take the 80 and subtract. It would look like this. And so if I just take my 80 and I subtract the 360, that'll take me and back me all the way around the circle to where I landed. So to find coterminal angles, you're going to take the angle they give you, add or subtract 360 degrees. So in this case, I'm being lazy here, going to my calculator, 80 plus 360, that's a 440 degree. And the negative version would be if I subtracted the 360. And that would be, oh, sorry, negative 280 degrees. You probably already had that in your head. Good for you. All right. Now, that's one scenario. What if I gave you it in radians? What happens then? And your first thought might be, well, hey, didn't we learn a way to convert that to degrees? Well, yes, we did. But we do not want to be dependent on having to flip back to degrees every time because we're going to use radians just as often. So we just need to be able to work with radians the same way we can work with degrees. And it's not that hard. Think about it. Well, if all I have to do is add and subtract 360, well, if I'm in radian measurement, then I'm just going to add and subtract. What do you think? Well, what's the same as 360 in radians? 2 pi. And so I don't need to convert. I'm just going to leave it in radians. I'm going to add and subtract 2 pi. Think of your 2 pi as over 1 because you're going to end up needing a common denominator here. So this is going to turn into 5 pi over 8 plus or minus 16 pi over 8. And this is going to keep my answer in radians because if I give it to you in radians, I'm going to want it back in radians. So that's going to get me a 21 pi over 8. And if I subtract it, I'm going to get a negative 11 pi over 8. Now, one quirky thing with this, though, is that, we've talked about how you can make these angles wrap around several times. And so you're going to start getting some bigger angles. They are always going to want, if you're looking for a positive and a negative, you want to keep your life as simple as you can. So you're going to want the smallest, closest to 0 angle that you can. So for instance, if I had I'm just going to make this up using my calculator. Let's say I had a 1,000-degree angle and I wanted a positive coterminal angle. Well, I could add 360 to it, and that'd be 1,360, but they're not really wanting that. They would rather you get smaller. Go smaller, smaller, smaller. Keep subtracting 360 until you can get the smallest angle that's still positive. And so what I typically do is something like that. If it's a really big angle, then I'm just going to subtract until it gets to be a negative. And then I know that's going to be my negative one, and the one right before it is going to be my smallest positive version. Hope that makes sense. I'm going to try it here. Let's look at this first one. I've got 23 pi over 4. Now, could you imagine where that would fall? I mean, you can sit there. Sometimes I actually have students that this kind of makes enough sense in their head. They could just figure this out in their head and not have to do the plus or minus 2 pi. 23 pi over 4, if you were to count that out, you're counting out in fourths. So here's 1/4, 2/4, 3/4, 4/4. 5, 6, 7, 8/4. Okay, so there's 8/4. So that means that's 16/4. And this would be 24/4. So 23/4 is right here. And so if you think in your head, if you know your radians, what is that positive radian value? This actually just happens to be a unit circle problem, so that makes it a little bit easier. Right here, do you remember what that was? That's 7 pi over 4. So that would be the smallest positive coterminal angle. Or if you think of it as backing up, because it's a negative, it'd be a negative 1/4 or a negative pi over 4. All right, if that makes sense, go for it. If not, I'm going to show you how we would do that. So you're going to take your 23 pi over 4, and at this point, it feels like I'm supposed to do plus or minus, but I'm already way too big. I don't need to add. I'm just going to subtract 2 pi over 4, and we really would probably attach an n, meaning do it n times. Keep subtract. Oh, sorry, hang on. Backtrack. It's not over 4, it's over 1. N. And I would sit there and subtract it n times. So subtract it once. If it's not where you want it, subtract it again, subtract it again. N just tells you how many times you have to subtract it. Okay, so I'm going to take my 23 pi over 4, change that to 8 pi over 4, and just keep subtracting. So I just, if you need to go to your calculator, you can just take 23 and you're going to subtract 8. Oh, now I'm at 15. All right, I'm going to subtract 8 again. Okay, now I'm at 7. Now I'm going to subtract 8 again. Now I'm at negative. Oh, okay. So what that means is the last positive version I had was a 7 pi over 4. And then when I subtracted once more, I got a negative 1 pi over 4. Those were the two that I just got done saying over here when I was looking at the graph. Okay, let's try it again. Let's say that the first one that I give you is negative. So now instead of subtract, 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 I'm going to add, and get it to be positive. All right, so again, because it's a unit circle, I'm going to go through this like you did it in your head. I know that it's so much easier, you think, to just do this all in my calculator. I never have to think about it, but the sooner that this makes sense in your head, the easier things in the future will be. So 6. So think about this. It's negative 162,636. 465,666. Oh yeah, right? Halfway around to be 66. So this is 12,6. I'm backing up. I'm at negative 12,6 there. 12. Okay, well, this would be 18, but I went too far, so I got to back up 1. So it's right here. So in my head, as a positive angle, that's 7 pi over 6. As a negative angle, it's a negative 5 pi over 6. All right, if you're going to do it by setting it up, negative 17 pi over 6. I'm going to add over and over 2 pi over 1 n times, however many it takes. We don't really do anything with that n. That's just implying that I'm going to do it multiple times. So I'm going to change this to negative 17 pi over 6 plus 12 pi over 6. So if I add it once, I'm going to be at a negative 5 pi over 6. If I add it again, then I'm going to be at 7 pi over 6, which were the two numbers that I had said, if I can think through it. Either way works for me. You just got to get them as close to 0 within that one revolution on your circle. All right, I'm going to call it quits there. And then we're going to take a break and we're going to pick up on more terminology and stuff tomorrow. But your homework tonight is probably on your My Math Lab, and get that done so you're ready to jump in tomorrow.